climate change drastically alters the way we've been approaching architectural design and building uses. Historically, some cities in the south of Europe, for example, have been designed with great thermal ingenuity to cope with the warmth of the summer months. But that's not the case of many other cities, which, like Paris, stem from much colder climates, in which keeping warm throughout the long and cold winters was a much more immediate imperative driving architectural conception. But now, as human-induced global warming shifts warm climate away from the equator, these cities are forced to endure temperatures that are ever more different from those for which they were initially built. In 2050, it is projected that the climate of Paris will be comparable to the one of Sevilla in the south of Spain today. This means that Paris now has to develop unprecedented cooling strategies to respond to new scorching summers. For instance, one of France's most memorable heatwaves was in 1976, the heatwave of the century, as some put it, during which the temperature in Paris rose to 35.6 degrees Celsius. This can seem like a lot, but in the last 5 years only, the temperature in Paris rose 5 times above 40 degrees, with a peak at 42.6 in 2019. 7 degrees more than the 1976 heatwave everyone remembered. While heatwave resilience will need to improve across all territories, it is even more critical for urban centers, as their materialities, geometries, and lack of vegetation trigger urban heat islands, soaring up temperatures to 10 degrees higher compared with surrounding rural areas. This reality calls for urgent climate adaptation, one that enhances cities' resilience with passive heat mitigation strategies, while limiting reliance on active cooling systems that reject heat outside buildings and worsen the adverse effect of heat waves.
Ever since we created Roofscapes Studio in 2021 during our studies at MIT, we have been researching, developing, and deploying passive heat mitigation strategies to base our interventions on low-tech yet effective thermal principles. First, we shade heat-absorbing surfaces in order to protect them from solar radiation, reducing indoor and outdoor temperatures. Then we plant ecosystems to create biodiversity corridors, and we further enhance passive cooling through natural evapotranspiration. Our primary site of intervention has been Paris' extensive roofscapes, where 4 out of 5 buildings has a pitch roof that typically contributes to urban overheating, with zinc reaching up to 80 Celsius under summer conditions. In partnership with the city of Paris, carpenter Mea Construction Bois and landscaper Topagé, we deployed our first pilots of passive climate adaptation on a former town hall building, now hosting the Académie du Climat. In July 2024, during the first heat wave after construction was completed, the results we monitored were staggering. The zinc roof's surface temperature dropped by 32 Celsius, and the attic space beneath it was cooled down by 17 Celsius. Our approach for the climate adaptation of existing buildings is about finding tactical and non-destructive strategies to pass on our built heritage to future generations. It is about leveraging what is already there and identifying the right intervention to adapt it to different climates. We call this climate realignment. For the roofs at Paris, it meant working with roofers, carpenters, and landscapers to deploy planted wooden platforms that protect roof surfaces from solar radiation. These platforms create shared gardens at the roof level, providing social and ecological benefits with minimum impact onto the underlying building structure. We are now collaborating with all types of private and public building owners to deploy such interventions across Europe.
As we're convinced that climate realignment doesn't stop at the roof level, we wanted to take the opportunity for the Biennale, one, to showcase other strategies that we've developed for the adaptation of urban centers, and at the same time immerse visitors in the realities of heat. One of the challenges of working with urban heat is that the phenomenon itself is invisible. To understand it and eventually to act on it, we need to sense it, we need to visualize it. We need to make the physicality of urban heat visible. This is why for the 2025 Venice Architecture Biennale, we decided to build twin models, each representing 3 building typologies that are ubiquitous in Paris. An early 19th century Faubourian townhouse, a late 19th century Haussmannian building, and a 20th century modern condominium. These models, made out of stone and plaster and zinc, and all the material used in actual buildings, have real thermal properties, which means that once they're exposed to heat radiation, they behave much like their real-life counterparts.
These models illustrate 2 possible scenarios. The first one shows existing buildings if the status quo prevails as the sun continues beating down on our cities.
The other features a range of architectural climate adaptation interventions that we're currently developing. Their comparison, filmed with thermal cameras, shows the impact of passive heat mitigation strategies. Shading balconies, vegetated planters, penthouse structures, curtain, creeper plants, solar panel canopies, water retention systems, and so on. To ensure that our cities can be adapted at the pace required by the climate urgency, while being mindful of our architectural heritage, it is necessary for architects to develop non-destructive, passive cooling strategies for both facades and rooftops. We believe that this experiment underscores a crucial message for architects and designers invested in climate adaptation. Our industry needs to investigate a new zone of architectural intervention, the 1.5 meter offset layer around the envelope of buildings subject to heat waves. More than ever, we need to deploy within this layer nature-based, low-tech, non-destructive, and scalable strategies to protect buildings and their inhabitants. We define this layer as our new site of architectural intervention, and it is this imaginary of climate realignment that we attempt to convey at the 2025 Venice Architecture Biennale.